the reason this becomes a handy thing is because you want functions to have state sometimes. So this thing here, this inc counter here, the reason this does anything interesting at all is because it has access to persistent state. So this val, it persists across multiple times that I call counter. If I define some other value locally like x, and we'll say x is equal to 0, and then in here we'll say x equals x plus 1, and then we'll return x instead of val. If I did this, every time I called inc counter, x would be 0, and then I would set it to 1 and I would return 1. So this would always return 1 every time I call inc counter. That's not what I want. What I want is, I want this thing to go up every time I call it. So I have to have some val that lives outside of this function that gets initialized here. And then every time I call inc counter, it increments that value. It doesn't create a new one each time I call inc counter. So that's what the closure lets me do. It lets me have some state that this thing can operate on. And I can also pass this function around and pass all of the state along with it. And we'll see why that's useful a little later on. Now you could get the same effect like so. So I'm going to go ahead and get rid of that for now. And just have a global variable. And here I have a little problem because I got rid of the value. So let me just go ahead and do that. But there's a problem here. So let's assume that what I had before was exactly what I wanted. So what I wanted was 3 separate counters, and I can increment each one of them separately. Is that what I have now? So how many vals do I have here? When I run this program, how many different vals will I have? Different variables named val will I have? Yeah, 1, 2, 2. I think I have 1. Because this one here, this is actually the same one as this because it's global. And this one, this is the same as this. So these are all this one global one. Yeah. So I only have 1 copy of val. And so all 3 of these counters are going to be changing the same copy of val. And look what I get. So my counter doesn't go 1, 2, 3, 1, 2, 3, 1, 2, 3. It goes 1, 2, 3, 4, 5, 6, 7, 8, 9, because each of my counters is accessing the same backup val. Yeah, since it's global, it's going to be constantly updating, adding on top of each other. Exactly right. Which is not what I want. I want to have separate counters. So if I do it this way, and then make this non-local, now I get a different copy of val every time I call make counter. So I have 3 copies of val because I call make counter 3 times, and I get, because I scrambled the order, so I get 1, 1, 1, 2, 3, 2, 3, 2, 3, because I mixed the order up of how the increments are happening. But I could also, initialize these to different values, so it's a little obvious what's going on. So now I get 10, 11, 12, and 101, 102, 103, and 11, 12, 13, in whatever order I happen to execute those counters. So the thing that having a closure does is it lets me have separate storage for each time I call make counter, and then each counter has its own separate counter value. If I just have a global, I can't do that. I can't make a new storage for each counter. So So there are some kinds of things that you can really only do in this way by having this closure here. Or you can use object-oriented programming, which accomplishes the same thing using a different mechanism. And we'll talk about that next time.